Okay, student, let's start our class for the first topic. Okay, linear algebra. Okay, all right. So, what is a linear algebra? Okay, so this is a branch of mathematics. Okay, contain linear equation. Okay, so what is a linear equation? So you can see here you have the variable. This is the x1, x2, xt until xn. Okay, so this is a variable. In front of the variable, you have the constant. You can see this is the right hand side. You have the constant. This is referred to the linear equation. So this linear equation, okay, linear algebra can represent by using the matrices and also vector analysis. So we focus on the topic 1a first. Is a matrices. This is a topic 1b. Here is a vector space. Here is a vector analysis. Okay, so we focus on these matrices first. Okay, so okay, all right. So matrix. Okay, what is a definition? So we can see here is a rectangular array of the number. So you can see here you have the matrix A here. Okay, you have the matrix A. You can see we put in bracket here is Aij. So Aij, what is Aij? So this is we call the entry or we call it element inside the matrix A. Okay, so usually I will use element, words element. Okay, so let's say you can see here, how come, okay, they are put, this is the 1, this is the 1, this is the 1, this is the 2. Okay, what is this? So you can see here, this is the Aij. So the I here is referred to the row number. Okay, so it's row number. So you can see here, the I here is a row number. This is a row number 1. Okay, it's row number 1. This is a row number 2. Okay, and this is the row M. Okay, row number M here. So I here is referred to the row number. How about J? J here is referred to the column number. Okay, column number. So where is the J here? The J here. So if you look our element inside here. Oopsie. Mana? Change the J. This is the column number 1. So you can see this is the J, right? It's a column number 1. This is a column number 2. This is a column N here. Okay, so make sure after this, okay, when I put it A11, so you have to make sure this is the row number 1, column number 1. So let's say I put it A3, 4. This is the element on the row number 3, okay, at the column number 4 here. Okay, so let's say you can see here this one. Let's say you have the matrix A M multiply with the N here. A M multiply with the N here. So M here is referred to the row. N here is referred to the column. Okay, so you can see here, when you have the M is not equal to the N, so it means you will have the matrix. So you can see here, this is a matrix here, is a the dimension for the matrix is M multiplied with the N here. Is order M by N here. So let's say you have M is equal to N. So we call it as a square matrix. So we can rewrite as a, before this we use the M, but now we can use the N multiply with the N here. So we know this is referred to the square matrix, means the number of row, okay, must be equal to the number of column. Okay, so next, this is just revision for you, okay? So this is equality. Let's say you can see here the matrix A and the matrix B here. You can see the dimensions same. You can see here number of row same, M. Number of column also same, X, okay? So when we want to check the equality, okay? Before that, we have to make sure the dimension must be same, yeah? The dimension must be same. If the dimension not same, how you want to check the equality? Okay, so for the when we put, okay, when we have a statement, matrix A is equal to matrix B here, okay, so you can see this is element for the each, okay, each element in the matrix A and each element in the matrix B must be same here, okay, so you can see this one, okay, you can see this is what is the dimension for the matrix A there, okay, you can see how many row is a 3, 1, 2, 3, this is the column 3 also. So this is the 3 times 3. And the matrix B here is also 3 times 3. So when we put the statement A equal to B means for the each, okay, for the each element must be same for the matrix A and the matrix B here. Okay, so you can see this is 1, this is 1, this is a 2, this is 2. What is a W? For sure, the W here is a negative 1. So this is same thing. What is your X? Your X here is a negative 3. So what is your Y here? Your Y here must be 0. What is your Z here? It must be 5 here. Okay, so this is the just division. Okay, next is a matrix addition and a subtraction. Okay, same thing for the addition and the subtraction. Addition, subtraction. We have to make sure the dimension also must be same. Okay, we have a two matrix A and B. Before we do the operation for the addition and subtraction, we must make sure the dimension must be same. Okay, so you can see this is the addition, just add element by element. So this is the subtraction, just minus, just do the subtraction element by element. So you can see here, this is the matrix A, this is the 2 times 3. Okay, this is also a matrix B here is a 2 times 3. Okay, number of row 2, number of column 3. So should be no problem to do the operation for the addition and subtraction. So for the addition, this is the just add. Okay, just add element by element. So this one subtraction. This is the negative 2 minus with the 2. You have the negative 4. 3 minus with the 1 become 2 and so on. So this is the operation for the subtraction and the addition. So next, scalar multiplication. Okay, this is the scalar, yeah? Not yet multiplication. Matrix with a matrix. This is scalar only. Okay, this is a scalar. Okay, this is not refer to multiplication matrix with a matrix. Okay, so for this one, you have the matrix A and multiply with the N. So you can see here, you have the C here is a real number. So the C here is refer to the scalar. Okay, it's refer to the scalar. So if you want to multiply your C, your real number, the scalar number here with your matrix A here. So you can see we just multiply the C with the each element in your matrix A. Okay, so you can see this one. You have the negative 2 multiply with the A. So you can see this is your matrix A. Okay, just multiply negative 2 multiply with the 1 is a negative 2. So you can see the negative 2 here is referred to your C here. So just multiply negative 2 multiply with the 2 become, this one should be, this is negative 4, right? How come it's a positive 4? Okay, this is the negative 4 here. Okay, this is become positive 4. This is become the positive 2, correct? This is the negative 6. This is the negative 8. So please do correction. This is the negative 4 here. Okay, all right. Next is a matrix multiplication. Okay, previously is a scalar. Now is a matrix. Okay, we have two matrix, A and B. Okay, so this one you want to do multiplication. Okay, so you ask me, Miss, this one multiplication, this is matrix multiplication. Why we need to know? We can press calculator. Yes, correct. You can press calculator. Okay, but I mentioned just now, we need to show the step. Okay, for the to have the full mark. Okay, so if you just press calculator and just give the answer, okay, so you are just get marks for the answer only, not for step. Okay, all right. So then you ask me, Miss, this question is a matrix multiplication. Okay, this question will for sure will not come out in the final. This one, because this is very basic. How come? For sure you will not come out this question in the final. Okay, no. Okay, this question come out in the last semester, January 2020. Okay, right? Many students shocked. This question come out. Okay, and fail to do matrix multiplication. Okay, so I will say this question is also very important. Okay, all right. So this one. Okay, so before you do the matrix multiplication, okay, so you can see this is the number of row. Okay, I will put it R. This is the number of column. So this one for the matrix B, this is the number of row. This is the number of column. Okay, before you do the multiplication between matrix A and B, so you have to make sure the number of column for the matrix A must be same with the number of column for the matrix B. So we can see this one, if you compare this one and this one must be same. T here. Okay, must be same. Okay, if they are same, for sure, you're able to proceed for the multiplication. Okay, let's say I want to ask you, your matrix A here is 1 times 3. You want to multiply with matrix B here is 4 times 3. Able or not? Jaime? Able or not? Can we multiply?
No,
okay, cannot, right? Okay, good. Why? Why, Jin Yap? Why?
Because it's different. It's not the same. The column from A and the row from B is not the same.
Correct. Good. Okay, not same. Let's say we put another one. You have matrix C here is 3 times 1. And your matrix D here, let's say you have the 1 times 4. Okay, so for this one, okay, can write because you have the number of column from the matrix C is the same with the number of row for the matrix D. Okay, based on this, based on this dimension, you also can determine what is the result. Okay, what is the dimension? Okay, for the matrix that you get. Okay, for after you do the multiplication. Okay, how? So you can see here. Okay, you can see here this one. Okay, for this theory here, this one. If we multiply A and B, you can see we have the M multiply with the N here. So you can see the final answer. Okay, you must have the matrix. Okay, matrix, where is the matrix? Is M multiply with the N here, dimension here. So for this one, if you look with this example number 1, let's say we will have the matrix E for the multiplication. What is a matrix E dimension for the matrix E is 1 multiply with the 3 here. Okay, how about this one? C multiply with D. So let's say you will have the matrix L. So you will have is 3 multiply with the 4 here. Okay, so this is dimension that you should have after you do the multiplication here. Okay, so how we want to do the multiplication? Okay, so we look here. Okay, you can see this is the formula here. Okay, so you can see here this one. Okay, is summation K is equal to 1 until N here. Okay, so you can see if it's hard for you to remember, right? Okay, so you can see here, this is the I here is a same, right? So you can see this is I here. For the A here, the I here is the same. Okay, but the for the B here is a column. Okay, sorry, the B here, the row here is the different here. Okay, let's say we want to do the matrix A is a 3 times 3. We want to multiply with the matrix B here is a 3 times 1. Okay, example. Matrix A here is a 1, 2, 3 is a Okay. Okay. Matrix B, this is a matrix A, right? Multiply with the matrix B here. Okay, is let's say we have the, okay, this is the 3 row, 1 column. Okay, so how to do the multiplication? The final answer you will have the matrix C is dimension here is a 3. Oh, 3 times with the 1 here. Okay, row, number of row is 3, column 1. Okay, so how to do multiplication? So you can see here this one, please multiply. This is the first one row. You can see here, this is the row number 1 multiply. Okay, this is the A11 multiply with the B11. Okay, and then we have to add up. Okay, and then this one multiply with this one here. Okay, and then add up. Okay, this one multiply with this one here. Okay, and then add up this. After do one multiplication, you add up. You will have the matrix C here is a 1, the element here. Okay, after you add up, you have the 1 element here. Same thing. Do the row number 2. You multiply. For this column by column here, you will have this element and the row number 3, and you do the this is row by row for the matrix B, you will have this is element. You can see this is the matrix C here is a 3 times 1 here. Okay, make sure you know. Okay, if you ask me means I just press calculator, no problem, you can press calculator. But for checking only, for checking, not for to give the answer. Okay, not to give the final answer. Okay, all right. So, okay, you asked me, okay, so you can see here, this one I already discussed just now. Okay, so you can see this is the A multiplied with the B. So you will have the matrix C here is the M multiplied with the N here. So you ask me, Miss, can I multiply B? I put it in front and multiply with the matrix A. No, yeah, the answer that you get will be wrong. Okay, so make sure you put the matrix A in front first and multiply with the matrix B, because the answer here is not same. Okay, so this is the, okay, just basic operation for the matrices. So next, this is example that you can use. Okay, for the matrix, okay, basically this is also, you can imagine how we can put the real problem in the system of linear equation, and after that we put it in the matrix, okay, and we solve it. Okay, so one local shop sell curry puff, have a 3 types. So the beef curry puff is a RM4 each, chicken curry puff is a RM3, vegetable curry puff here is a RM2 each. So this is the table. Okay, this is the table for the Monday, Tuesday, Wednesday, Thursday. For the beef, this is the how many pieces. Chicken is how many pieces. For the Monday, this is vegetable, how many pieces. Curry puff that this is a local shop sold. Okay, so this is for the Tuesday, Wednesday, and Thursday. So how we want to put in a matrix? Okay, so you can see here. Okay. All right, how we want to put it in matrix. So by the way, what the question want? The question asks how many they sold in 4 days. Okay, how many they sold in a 4 days means we want to have, okay, the cost, the how much they get, okay, for the money that this local shop get, okay, for the Monday, Tuesday, Wednesday, and Thursday. Okay, so for the first thing, we put it in the matrices first. Okay, so we know the cost for the, okay, for first of all is a beef, chicken, vegetable. So this is the cost for the beef, vegetable, and beef, chicken, vegetable. This is for the beef, yeah, chicken, and the veggie. Okay, this is a cost per pieces. Okay, and then this is the, okay, this is the next matrix here. Okay, is the, this one is the first row is a Monday, this is a Tuesday, is a Wednesday, Thursday. Okay, so we put it in the matrices. Okay, so you can see here, if we do multiplication, first of all, before we do multiplication, check first. Can we do multiply these two matrices? This dimension is 1 times 3. Okay, and this is dimension here is a 3 times 4. Is it can or not? For sure can, because this is the same here. So the final answer must be the matrices is a row, 1 row, okay, 1 row, 4 column here. So you can see here, after we do multiplication, you can see we will have the cost. The shop can get the 88 ringgit for Monday, Tuesday 65, 40 ringgit for the Wednesday, Thursday is 84 ringgit. Okay, so this is when we cover it in the problem. Okay, can? Right, any question from the basic operation? This should be the problem, right? Okay, so next. Okay, so this is a transpose. What is a transpose? Okay, this is one operation that you need to do, okay, for the letter when you want to find the inverse matrix, okay, inverse matrix, okay, for the 3 times 3 matrix. So you need to do transpose. Okay, so first of all, okay, we learn first what is a transpose. So for the transpose, we can put a notation. Let's say you want to transpose matrix A. So you can see we have the small letter T here on the top here. So this one is referred to the transpose here. Okay, it's referred to transpose. So you can see here, if you want, you can see the matrix A here is a AIJ. So when we do the transpose, you can see here, now the J here, previously the J here is the number of column, but now your J here is become in front here, row. Okay, so this is your I here previously as a row, but now this is become column. So it's okay, no problem. If you not understand here, we look example. So by here, you can see what when we do the transpose, we need to interchange row and the column. Okay, it's all the element in your matrix A. So you can see here for the first row. Okay, this is the first row. Okay, we can see the row here is become first column. Okay, you can see the first column. Previously is a row 1, but now it's become column number 1. So you can see this is 1, this is 1, this is a negative 2, 3, this is the negative 2, 3 here. Okay, this is for the first, okay, row here for the matrix A. This is a row number 1. How about the row number 2? For the row number 2 here, this one. Okay, so you can see this one. Sorry. This one is a row number 2 here, this one. So it's become column number 2 here. So this is the transpose. Okay, make sure you know, yeah, transpose. Okay, next, this is a basic operation for the matrices. So let's say, okay, the question asks you, okay, want to test you the understanding about the property, algebraic property for the matrix operation. Okay, so how for this one? Okay, so let's say you have, this is matrix A, B, C. Okay, this is all matrix. Yeah, this is okay. This is all matrix. Is dimension here is M multiplied with N here. So if you do the addition, okay, for the A and matrix B, okay, is okay if you want to put the matrix B in front and you do the put A at the back here, and then you do the addition. Both are same. Okay, left hand side and right hand side same. Okay, this is the same thing. If you want to do the addition for all matrix, so you can say you can do the summation, do the addition matrix B and C first. Okay, and later you do the addition with the A, matrix A. Okay, same thing, you can do the addition for this one, and then you add with matrix C. This is the same thing. Okay, the addition is no problem for the matrices. Okay, and then this is the you can see 0. This is 0 matrix. Yeah, this is, you can see here is referred to the 0 matrix, means all the element. Okay, all the element equal to 0. So if you do the addition with all the element matrix with all the 0, for sure, you get back your matrix A here. Okay, so you can see this is referred to the 0 matrix here. Okay, so next for the each, okay, so you can see this is additive identity. So this is operation here. This one we call it is a additive identity. Okay, so next for the D here, if you have, okay, matrix A plus with the matrix D here is equal to 0. So we can conclude that, okay, the matrix D here is actually is the you can have the element for the matrix A is multiplied with the -1. So we can make conclusion that this is a negative A here. We call it the additive inverse of the A here. Okay, so because of this A, same thing here. Let's say you want to you have the C plus D is equal to 0. Okay, so it means you will have your B here is equal to -D. Okay, so mean all element in your matrix D here, they say this is 3 times 3 matrix, you need to multiply with the -1. Actually, this is the equal to your matrix B here. So this negative D here, we also can call it is additive inverse of matrix D here for this case. Okay, all right. So this is the next here is a scalar multiplication. This is the same thing as I introduced you before. When you have the C and D here is a real number. This is not the matrix here. Your C and D here is not matrix. Okay, it's real number. Okay, it's not matrix, real number. So if you multiply with the A, so it's up to you if you want to multiply your D first, okay, with your matrix A, and later you multiply with the matrix C, with the real number C, it's the same thing, or you want to do multiplication first and multiply with the matrix A. Okay, it's the same thing. So for the B here, this is the I here. What is the I? Identity matrix. Okay, so identity matrix, if you multiply with the any matrix, for sure you will get back the matrix back here, the matrix that A back here. So for this one, for the addition, okay, if you do the multiplication with the scalar here, you can expand and then you do the addition. This is the same thing here. You can expand, multiply first, and then you do the addition later. Same thing. Okay, all right. So this is for this one. Okay, this is for the first one. Roman 2 here is a scalar, but the Roman 3 here is matrix. When you have the all of this here is matrix. When you want to do the multiplication here. So you can see here for this one, you can see if you want to do multiplication A, B, C, okay, you have to make sure the sequence here must be same. Yeah, the sequence for the right hand side and left hand side must be same. Okay, but it's okay, no problem. If you want to solve this one first and later you want to multiply with the A, okay, or you want to solve the A multiply with the B here and you multiply with the C. But you have to make sure the sequence A, B, C on the right hand side and left hand side must be same here. Okay, same as the B here. For this one also, when you do the addition, okay, for this one is okay, no problem. Okay, you can multiply this one, but you have to make sure, okay, you have to make sure the A here must be in front, okay, and the C here must be at the back. For this one also, B here must be in front, okay, the C here must be at the back here. So if you change the C multiply with the A here, plus the C multiply with the B, for sure the answer here not same here. Wrong, yeah? If you give the answer, you do this operation will be wrong. Okay, same as this one. Okay, I mentioned the B and C here same. The same property here. So you can see the C here must be in front here. Okay. And this one, you can see this is the C, small letter C here is referred to the real number. So you can see here for this one, you can multiply the real number with the matrix A first, or then you multiply with the matrix B. Or you want to solve this one first and multiply with the real number is also okay. Both are same. Okay, any question for this one? Easy, right? Already know, right? Okay, so next. This is transpose, property for the transpose. Okay. you have the A matrix, then you do the transpose. And then you transpose again. For sure, you get back the matrix A. Okay, before this, the T here, if you only have AT, means you already change the row and the column. And then if you transpose again, okay, for sure you get back the A here. Okay, so next, for the B here, you have the A plus B. Okay, you do the transpose here. Okay, actually, okay, to avoid confuse, you can do the transpose first. You can transpose the matrix A first, and then transpose the matrix B, and then later you do the operation for the addition. Okay, and then for the C here is quite unique, because previously I informed that matrix A and B, if you do the multiplication, is not equal with the matrix B, A, right? It's not equal. Okay, but for when you do the transpose, okay, have the equality. When you multiply A and B, and then you do the transpose, is actually equal to B transpose multiplied with the A transpose. So this is the property number C here. Okay, right? So this is for the C here is a real number, and then you multiply, you do the transpose. Actually, you can transpose first your matrix A and then do the multiplication with your real number, the scalar here, the C here. Okay, so this is the property. Okay, any question? Okay, I think you no problem, right? Okay, before I move to the determinant. Okay, so determinant 2 times 2. So this is when you have the matrix is the dimension is a 2 times 2, means the number of row here is a 2, number of column is 2. When you want to find determinant, easy, right? Easy, okay? Because for this one, you just multiply, okay, from the top on the left, we multiply with the right here. Okay, so this one is a A11 multiply with the A22. And next, okay, and next you just multiply this, okay, and this. And then you do the subtraction. Okay, so this is the 2 times 2, easy. Okay, so what is the symbol for the determinant? This is a matrix A. You can see you have the parallel line here. Okay, so this is, you can see here, this one is a example. Okay, so this one. Okay, so I think should be, you already know, this is a 3 times 2 minus with the negative form multiply with the 1. Okay, so you will have the answer is 10. Okay, so you can write like this, yeah. You can see you have the parallel line here. Okay, this is the matrix, then you put it parallel line. This is also same thing. So multiply with a 0 and then minus with the negative 6, multiply with the 6 here. You have this determinant. Okay, so next, and this is the critical part, when you have the matrix here is not 2 times 2, but it's more than 2 here. Okay, so we look first for the dimension for the 3 times 3. Okay, so you can see, this is the element that we have. Okay, the row number 1. Okay, that's why I asked you to familiarize with the element, how we denote the element here. This is the number of column. Number 1, column number 2, column number 3. Okay, all right. So we look how to find determinant. So we can see here, we want to find determinant A. So we use the row number 1. So we can see here, this is the row number 1, the first column, A11. And then we need to multiply with the cofactor for the A11. And then we do the addition. This is for the column number 2, A12, and the cofactor for the A12 here. And then plus A13 and the cofactor for the A13. Okay, so by the way, what is a cofactor? Okay, what is a cofactor? So cofactor we can write down as a C, small letter ik on the below here. Okay, let's say we want to find the cofactor for the A11. Okay, you want to find the cofactor for A11 mean this is the C11 here. Okay, so this one. Okay, A12 mean, okay, A12 mean cofactor A12. Okay, by the way, how to find the cofactor? So you can see this is the formula here is a -1 power of I plus J. Mean we need to do summation. We need to add up 1 plus 1, this one. Okay, 1 plus 1. Because this is referred to the I, this is referred to the J. And this is the -1, I is a 1 plus 2. Become power of 3 here. Okay, right. So this is the, for the first, this. How about minor? What is a minor? How about minor? So the minor here, okay, so we can see here, let's say we want to find the cofactor for the 1, 1, 1. Okay, we already know this is a -1. We have the power here is I is 1 plus 1. And we need to multiply with the minor of, by using the formula here, okay, minor of the A11. Okay, minor of A11. So how to find this minor for the A11 here? This one. Okay. This slide, we want to objective A11. So you can see here, A11, this is refer to the row 1, right? Okay, so I mean you have to delete row 1. Okay, and the second one here is refer to the number of column. Is a column 1. So mean you have to delete the column 1 here. So you can see here, this is your minor here. A1, A22, A23, this is the A32, A33 here. So what is a minor? You need to find, okay? You need to find determinant of this matrix. So you can see here, this one, this is the same, right? With this one, you can see we have the parallel line here, meaning we have to multiply this with this with this, and do the subtraction. We need to find determinant for this matrix. This is the minor. Okay, for the entry for the element A11. So we look more. We want to find the minor for the A12. So I mentioned the 1 here is the row. The 2 here is a column. So I mean we have to delete the row number 1, okay, and the column number 2. So you can see this is the A21, A31, this is A23, this is the A33. Then you have to find the determinant in order to have the minor A12. So this is the minor for the A12. Okay, so for the A13, this is the row number 1, delete. Column number 3, delete. So you can see this is the matrix that you obtain, then you need to find the determinant. Okay, so this is the minor. Okay, so by now, so you can see here, you already know how to find the, okay, determinant. Okay, so you can see here, I use the determinant, I use the element from the row number 1. If I want to use the row number 3, is it okay or not? I don't want to use the row number 1 here. Element, I want to use the row number 3. Is it okay or not? Okay or not? Row number 3. Oh, I think, yep. Yep, I want to ask something, right? Okay. Okay, can. Okay, good. Okay, anyone want to ask a question just now? I think someone is raised your hand. Wai Sheng, I think right, Wai Sheng. Right, Wai Sheng. You raise your hand? Okay, so it's no problem. Okay, so if you want to find the row 3, so I mean, what is the formula here is A31. So multiply with the cofactor, okay, of the A13. Okay, plus with the A32 multiply with the cofactor of the A32 plus with the A33 cofactor of the A33 here. Okay, so same thing. It's up to you. Maybe you want to use the row 3 because maybe the row 3 main is 0, got 0 here. So easy for you to calculate. No need to find the cofactor for this because this one for sure, this first term for sure we have 0. Okay, it's no problem. Okay, all right. Okay, so all right. Okay, this is example. Okay, so for the first example, okay, I use the this is the matrix. Okay, so you can see here I use the row number 1. We have the first one here is a 12. Okay, plus the second term here is A12 here. This is A12 here is a this is a -1 here. Okay, and this is the third term here is a 3 here for the A13 here. So this is the cofactor. You have to make sure you can see this is a multiplication with the -1 power of 1 plus 1 here. Okay, and this is the minor. So you have to make sure for the first one, we look the minor A11. We delete column, row 1, column 1. So we can see we have this matrix on here. So we find the determinant. Okay, make sure you do this operation first. Okay, next for this one, minor A12. So delete row 1, delete column 2. So you can see you have this, you have this. Okay, this is next. This is a minor A13. Delete row 1, column 3. So you can see this one should be here. Okay, and find the determinant. Okay. So I know some of you already have the another method. Okay, Miss, I don't want to do this because this one very tricky. This one, right? We need to multiply. If you have the even power, for sure, this one -1 here is become positive. This is become carry the positive sign. This one, when you have the odd power, you will carry negative. And this one is a even power, power 3 plus 1 is even number, right? So this is carry the positive here. Okay, if you ask me, Miss, I don't want to do this operation. Okay, I don't want to do this operation. I just directly write down on this. I write down like this. The student just write down this first row for sure positive. This first column is positive. The second column here is a negative, and then the third column here is a positive. The student write down for sure this is the alternate sign. Okay, start with a positive. Okay, and then the student just write down the positive, the A here, they use the row number 1, right? Use number 1. The A here is carry the positive. Okay, and then the second term here, the B here is a carry the negative. That's why you can see we have the minus at the outside here. Okay, and then the third term here is a positive. So you can see this is the positive C here. So if you don't want to write down, you want to put the minor like this one, the power here is also no problem. You can write down straightly like this. No deduction, okay, on your marks, no problem. Okay, just make sure, okay, the sign here, the must start with a positive, and this is the negative, this is the positive here. Okay, cofactor of A31 here. Okay, all right. This one is it? Oh, sorry. Thank you. Okay, cofactor 3, 1 here. Okay, so all right. So I mentioned I want you to show this tab this tab. Again, you have to write down what is the minor that you use. Okay, minor that you use. Okay, and this is when you have the matrix is 4 times 4 times 4. Okay, this is the same thing. This is for the A, B, C, D, E, F, G, H, I, J, K. Okay, by the way, okay, for your information, we just test you for the matrix entry 3 times 3. Don't worry. Okay, we just test you entry matrix 3 times 3 only. Yeah. Okay, 3 times 3 only. Okay. All right, so this is a property for the detail. Oh, sorry, I think we already enough time. On time already, 2 o'clock. Any question that you want to ask? Okay, for those who want to ask any question, you just can stay in this session and just unmute your microphone, or you can type your question in the chat window. I will entertain you. Okay, I'm still here. Maybe 5 to 10 minutes in this session. Okay, for those who have class, you can dismiss, or you want to dismiss is also no problem. Just make sure you scan your QR code. Okay, I think that's all. I think that's all. Have a nice day, everyone. Okay, any question you want to ask? Okay, so if not, we see you tomorrow. See you tomorrow. Can Sarus rule? What is a Sarus rule? Zhao Ming? You can something. You can message me if you want to ask more detail. Oh yes, Zaru's rule. Yeah, I know. The Zaru's rule is like this, right? Like this. The example. One. Student, just put this is the row number 1. Sorry, column number 1, column number 2. They put it like this. Okay. And this one is it correct, Zami? And then you do the multiplication like this, right? And then you do the multiplication like this. Okay. And then you do the multiplication, this one multiply with this one multiply with this one, and this one multiply with this one, right? And then you do add up, and this one multiply with this one, right? Okay, if you want to do this, it's also no problem. Okay, it's also no problem. But this is very important. Let's say, okay, let's say you do the careless mistake, yeah? You multiply 12, you multiply with the 1, you multiply with the -3. Let's say you multiply wrongly, yeah? Let's say you put it, should be is a -36, right? The multiplication, but you put the positive 36. Okay, it's positive 36. Okay, because you multiply wrongly, yeah? Okay, so you will have, okay, no marks, yeah? Since this is a question here, is you just do multiplication, is automatically you will have no marks for this question, because this is the, okay, I cannot give you marks. How I want to give marks here? Okay, if you do this step, I know, okay, you already arrange like this. Okay, maybe you have you put wrongly, this is the you put it, this is negative. Okay, you put it wrongly here, it's a negative, but should be here is a positive. But you still get mark because you already state what is a minor that you element that you use, what is a minor that you use here. Okay, but if you use this step, if you multiply wrongly, everything is wrong. Okay, I cannot help you to give the marks here. Okay. Can tell me? Okay, it's no problem, but I afraid if you do the careless mistake, you will not have a marks. Okay. Any question for others? Okay, welcome everyone.